Hello everyone, I am MS Bhagavathimmal, Assistant Professor of Computer Science and Engineering Department, Rohini College of Engineering and Technology. Our subject code is CS8691 and our subject title is Artificial Intelligence. In Unit 2, we are going to discuss about the topic is Constraint Satisfaction Problem. And what is constraint satisfaction problem? Constraint satisfactory problems, as the name suggests, are the problems which have some constraint which need to be satisfied while solving any problem. In solving the constraint satisfactory problem, an agent has the following parameters to consider: a set of variables, domain, and a set of constraints. Then set of variables are like empty containers in agent where the data is to be placed. Then set of variables, the collection of all the variables that the agent uses to solve that particular problem is known as the set of variables for that problem. Then domain. Domain is the field in which knowledge is to be obtained by the agent. Any problem deals with the information or data in any particular field and the domain defines this field. A domain can simply be defined as what data or information is to be collected or placed. Then set of constraint. It is the collection of all the restriction and regulation that are imposed on the agent while solving the problem. The agent cannot violate or avoid these restrictions while performing any action. Then set of variables is considered as x1, x2, xn, means a set of constraint is c1, c2 up to cn. Then xi has an non-empty domain of di. In general form of the constraint satisfaction procedure. The first one is select an unexpanded node of the search graph. Then apply the constraint inference rule to be the selected node to generate all possible new constraints. Then if the set of constraint contains a contradiction, then report that this path is a dead end. If the set of constraint describes a complete solution, that report success. If neither a constraint nor complete solution has been found, that apply the rules to generate new partial solutions. Insert these partial solutions into the search graph. Then constraint satisfaction problem has the above mentioned parameters like xi equal to va, xj equal to vj, like that. These are many used in many games and puzzles which lie under the constraint satisfactory problem. Commonly it known as Sudoku, n-coins problem, map coloring problem, crossword, and cryptic arithmetic problem. In solution of constraint satisfaction problem, each state in CSP is defined by an assignment of values to some or all the variables. An assignment that does not violate any constraint is called a consistent or legal assignment. A complete assignment is one in which every variable is assigned. A solution to a CSP is consistent and complete assignment. Then the final one is allows useful general purpose algorithm with more power than standard search algorithms. Here I given one graph, that is map coloring. Here the variables x equal to WANTQNSWVSAT. WA, it stands for Western Australia, then NT for Northern Territory, Q for Queensland, then NSW for New South Wales, and V for Victoria, then X for SA for South Australia. Then domains DA equal to red, green, blue. Then constraints or adjacent regions must have. Then here we change the color depends on the constraint satisfaction problem. The solution is complete and consistent assignment. Then here the constraints adjacent regions must have different colors. For example, WA is colored by red and NT green, Q red and NSW green, then V for red, then SA for blue, then T for red. Then constraint graph. Constraint graph having the variables or nodes of variables, then arc and constraints. binary CSP. Each constraint relates two variables, that is CSP conform to standard pattern, a set of variables with assigned values. Then generic successor function and goal test, then generic heuristics, then reduce complexity. Thank you all.